Okay, we are into our third video, or our third lesson for Chapter 6, Linear Relations. And so we're going to start looking into, well, what is a linear relation? And how do graphs show linear relations? So we have 3 goals for this lesson. So by the end of this lesson, we should know what a linear relation is, how to describe it. We should know what a graph of a linear relationship looks like, and we should know how to interpolate data. So that's going to be a new keyword that we look at. Okay, so I would encourage you to write in your box what a linear relation is. You can use your textbook, you can use your notes, just give yourself a reminder. But basically what a linear relation is it's a relationship that when you graph it, it creates a straight line. And that straight line can be a vertical line, a horizontal line, a diagonal line, but it doesn't curve and it doesn't zigzag. So then based on that, we need to figure out, well, which of these lines actually are linear relations. Okay, well, first one, again, we have a straight line, so a linear relation. B is a linear relation. C, there's nothing there, so no, that's not a linear relation because there's nothing there. This line, yes, it's straight, but it's zigzag, so this is not a linear relation. F is a linear relation, and Z is a curvy line, so that's not a linear relation. Okay, so just kind of getting an idea of what do linear relations look like. So looking at this next example, it says, what can we say about the pattern from the following graph? So what I would like you to do is, taking a look at this graph, I would like you to write as many different things as you can tell me about this graph. I'm thinking like at least 4 things, maybe 5. Everything that you can tell me about this relation based on the graph. Maybe where does it start? How does it change? All of that kind of stuff. As much as you can. We're going to go over this example together tomorrow. Okay? I will do this example with you. I know we usually do it the other way, but I'll do B with you first. And so looking at this relation, we can say, well, the points make a straight line on the graph. So we could say that it is a linear relation because the points make a straight line on the graph. We could say that, when x equals 0, so when x equals 0, we follow it up, y equals 450. Okay, so maybe this is talking about a plane decreasing. So at time of 0, the height of the plane is 450,000 kilometers above the ground or something like that. And it's decreasing, so maybe it's coming into land. Stuff like that. We could say that the line is decreasing. And how much is it decreasing by? Well, every time we go down 100, we go across 10. So we're going decreasing by 100 every increase of 10 on the x. Okay? Or what? Actually, let's use horizontally and vertically. That's probably good. Oops. So decreasing by 100 vertically as we move 10 horizontally to the right. Okay, so we're going down 100 over 10, down 100, right 10, down 100, right 10, and that pattern would continue. And then the pattern appears to end at this point. Okay, so we could say ends at when y equals 50 and x equals 40. We could say something like that. So starting point, ending point, how does it change? And in what direction is it changing? Is it going down or is it going up? Okay, next keyword we need to look up is Interpolate. So I would like you to freeze, take a minute, figure out what does interpolate. Here's a hint. It's got the word inside of it. That's key for you. Okay, so interpolate means estimating a value between two given values. And when we say the word between, we mean in, like it's in between them. So interpolate has the word in, and so we're looking for a value that's in between two values that we already know. So if we go back to our graph in B, we could say, okay, well, we know when x is 10 that y is 350, and we know that x is 20, y is 250, but what about when x is 15? So we would interpolate, okay, well, 15 is halfway between 10 and 20, so then we would need to be somewhere between 350 and 250, so it should be 300. So we interpolate. We look inside the data to find another piece of data. So here's another example for you. Weather balloon recorded air temperatures at different altitudes. So altitudes are heights above ground. And the data represents a linear relationship, but it says approximately. So what that means is maybe every single point isn't exact. Now I know that when this photocopied for you, the graph is quite light, but hopefully as you're watching online, you can see the video pretty well. So first thing we want to do is we want to put the data on the graph. So we have altitude and we have air temperature. We need to think of which one is dependent on the other. While the altitude is going to change no matter what. Just because it's 10 degrees doesn't mean we're at a specific altitude, right? So the altitude is going to be the independent. And then, so the temperature is dependent. So the temperature depends on what altitude we are at. So that means if altitude is independent, it is going on our horizontal axis. So this is going to be in meters, the altitude. And then the temperature in degrees Celsius is going to be our dependent variable, so it goes on the vertical axis or the y-axis. So we need to place the data on the graph as best as we can. So we have an altitude of 350, so I'm going to go to 350, which is somewhere between 2 and 400, but a little bit closer to 400. And then I need to go up to a temperature of 11.4. So that's going to be approximately there. That's my first dot. My second dot has an altitude of 750, so I have to kind of estimate again. It's going to be somewhere between 600 and 800, but closer to 800. And up to a temperature of 5.7, so go to 5 and then just a little bit above. Okay. Make those dots a bit bigger. An altitude of 1,000, so that's right on the line. I don't have to estimate that. And up to a temperature of 2.1. Well, 2.5 would be right in the middle, so this one's going to be a little bit below the middle. Keep going. 1,500. That'll be right between 14 and 1,600. And then -5 temperature, so that's going to be exactly on the -5 line. And then 1,800 meters, that's exactly there, and then -10. So that's one of the points we know exactly. Okay, so place the data on the graph. Now I would like you to use a ruler or something straight just to sort of see, does this make a linear relation? So basically what's going to happen is if you take your ruler, and I'm going to take a line, and so if I take a straight line, and now this tool, I can make a straight line in any direction. So I'm going to make a straight line. You notice that most of the points hit that line. Some of them might be just a little bit above or a little bit below, but again, I've kind of estimated where my dots are. But they pretty much fall in a straight line. So we can say that this is approximately a linear relation. It's pretty close. Maybe if we had a better graph or a more accurate graph, then we could see better if it's linear. So now we're asked to interpolate the approximate value for the air temperature when the balloon was at a height of 600 meters, so an altitude of 600 meters. So 600 meters, that's here. So again, maybe using your ruler, you're going to trace up. I'm going to grab another straight line, but I'm going to grab a dashed one, and I'm going to go at 600 meters. We interpolate. and see where does it cross our data, and it crosses about here, and so that's somewhere between 5 and 10 degrees Celsius. So maybe we want to see, say it's about 7 degrees or 8 degrees or somewhere in there, maybe somewhere between 7 and 8 degrees Celsius. Okay, maybe it's 7.5. I don't know how specific you want to be. We're interpolating, so we know that it's an estimate, right? It says approximate, and when we say approximate, it's going to be an estimate. We can't be exact. But it's a pretty good guess. C says, what was the altitude, the approximate altitude, so again, we're estimating, the approximate altitude of the balloon when the temperature is negative 7.5. Okay, well, negative 7.5, here's my temperature, so negative 7.5 is going to be somewhere between negative 5 and negative 10. Again, I'm going to use a ruler, straight line. I'm going to start approximately at negative 7.5 and trace it out to my data. Okay, and then where the lines meet, which is about here, we could say that that's pretty close to an altitude of 1,600 meters. Maybe a little bit below, maybe a little bit above, but we're looking at ishes here, so it's approximately 1,600 meters. Lastly, is it possible to interpolate the precise value for air when the altitude is 1,050.92 meters? So precise, this is saying the exact. And if you look at that altitude, that's a pretty exact. So I want you to answer, do you think it is possible? You're going to say yes and why, or you're going to say no and explain why. I'm more looking for your why than your yes or your no. So that is it for your third lesson. Please make sure you have the pieces you need to have completed by tomorrow.